Security architect with decade plus experience in cloud security, internal penetration testing, and security automation. He is also a host of a podcast channel, CyberGPT Pulse. He's also passionate about integrating security seamlessly into CI/CD pipelines, infrastructure as code, and engineering workflows. And he has helped shape security culture at scale. Aamir is also a frequent speaker, having shared his insight at DEF CON, Black Hat, and many other security conferences. His talk, Hidden Risk of Cloud Supply Chains, Securing Third-Party Integrations, highlights unseen vulnerabilities introduced by vendors. With that, please welcome Aamir.
Yep, thank you Angad there. So pretty full house as expected for the last talk. So welcome to the talk there. Just to add one thing which Angad forgot about, I happen to be a published author as well from supply chain. It's kind of a title, Supply Chain Software Security, recently published with A-Press. If you want, you can scan the code and get the link there. So I will just skip that. So from supply chain, specifically if we talk about supply chain, it's usually people think about the shipping containers moving around from one point to another, and how they actually provide the goods from one country to another. But specifically for supply chain software security, you can extrapolate that idea into a software thing. We have various components of supply chain security. In this case, I am just covering the cloud part. The first component is the assembly line. Just like in manufacturing industry, we have an assembly line. In this case, the assembly line is CI/CD tool, the continuous integration and continuous deployment tools. It can be GitHub Action, Jenkins, those usual tools which major companies, non-IT, IT companies does use. The second component is the open source modules and libraries, which kind of is a building block with their own dependencies coming around, because these kind of include into the third-party dependencies when we have to consider them in our supply chain. The third component, which in the last talk as well, John was sharing, that there is a SaaS component and there can be shadow SaaS as well. Shadow SaaS is simply anything being shared through Google Cloud or any unauthorized medium, which kind of very tricky to keep the track as well. Even in my organization, which I worked 3 years ago, when I joined there, I was pretty surprised that okay, I can just copy and paste into my own personal G drive, and then I can open it anywhere else. It's not just for the code space or notebook LLM. It's even easier for the non-IT personnel. They can do this stuff. So what you can do, it's kind of that's another risk. And the third particular thing which this SaaS provides the integration, and the fourth particular thing is API integration, which kind of gels on all the services being provided until now, which we have discussed. So, and the last one will be the platform, the basic gelling building block. It can be any cloud provider, and from that perspective, we have limitation as well as advantages based on which cloud provider we are talking about. So then the best practices, which usually is always talked about when we talk about any supply chain software security or cloud security. The first one is always SBOM. We have to maintain SBOM to know the list of inventory. Part list and the item to be component list to be assembled for a car or any manufacturing ideas. Similarly, we have SBOM in our industry. We also have HBOM, which kind of is a hardware bomb, which just like in manufacturing sector we have components, the list of all the item. In HBOM we will be having the list of the processors, the type of processor we are using in the IoT component, the type of the memory we are using for that. So the whole thing that also we need to be maintained. But in the cloud perspective, we usually talk about SBOM. So the second important thing is regarding the dependency scanning. Just like as we have discussed, with open source technology, we have to have a lot of libraries and third-party dependencies in our supply chain. So we have to have some dependency scanning tool. It can come with your SCA, or if you are having some pre-hood commit, you can also do from there. Embedded, we will discuss that later. And the last one, which I skip AI part here, just because I have heard every talk has added Gen AIs. But yeah, zero trust security is another theme of this RSA, so that has been put in here. So we require that, but how we will achieve that, that's a whole different discussion. We are not going to get into that. So the second one, what's the life cycle of cloud supply chain? So from the perspective of cloud supply chain, is kind of similar what we do in any CI/CD pipeline. We have to have the first step is pre-commit hook, which will be even before the code is been pushed into the shared repository. It's kind of first to provide the necessary security check. It can be the testing check as well as the error and those simple syntax checks as well, and those lintings which can be done, and also some dependency scanning can be also done in the pre-commit hook. The advantages of this is just to even shift left to the first step. Even before getting into the implementation, we are checking it at the time of pre-commit hook. And from my personal experience, this kind of very advantages. I have also seen adding, actually recommended and added secret detection in this step. Although it's not always thought about to have secret detection in pre-commit hook, but this kind of helps. Sometimes you just find out, okay, so deliberately a particular test environment was tested on, and then someone forgot to just remove the secret from the environment, and then just decided to push it into production. So before that, we can actually detect it. From IT environment, this kind of very naive to say that something like this will happen, but in manufacturing, from the perspective which I am seeing, is the test engineers are not usually IT engineers. Those are mostly with embedded background, with those electronics background, and they are mostly testing this on their test system, the test component, the full physical component. So they are testing it on the physical component, and then coming around there, yeah, okay, so see, these kind of things are working and these are not working. So once that work completed, they don't consider that, okay, so this secret which was physically in my test tool can be very dangerous, but it is been pushed to the production. So although they know this can be dangerous, but at the time of, it's kind of a long cycle of. And another thing which I would like to add, in the manufacturing cycle, the test to production is much longer than what we see in IT. So this was even another experience which I got. So you might tend to forget that, okay, I had something which opened, even sometime SSH connection was made just to provide the maintenance of that component, and then you turn off the connection, you turn off the port, but you forgot to remove the SSH secret. So that can happen. It's kind of a human error, so you cannot blame there. So then the second stage will be the version control, GitHub or any other shared repository. At that time, you will be sharing the repository, the code base or code base into the version control. And at this time, usually the version control system does have their own pre-checks. Those kind of can be specifically for NPM. They do check for the version. They do check for if NPM pack or NPM install is having some explicit malicious code, then that will be trying to block. They do check for the connection as well, but that can be also bypassed. That we will discuss today. And then the third stage is the acceptance of CI/CD. That's another stage where we just run the whole a whole code into our production for a continuous connection with other repositories, as in for the application. And the last two are related to the container images. Once the image which has been created at the time of CI/CD acceptance, the container, it can be any type of container registry, but that's kind of a storage factory of the storage component of this software or this cloud software factory, which will store these container images. And then the last one is the orchestrator, which will be just work on how these images will run in our application to achieve the target there. So that's going to be any Kubernetes and other stuff. So as we talk about from left to right, you can see the mode of hidden risk increases as we move from left to right, because specifically for container orchestrator, you might be using some vendor or some self-hosted Kubernetes, depending on your choice of poison there. So in that case, the chances of misconfiguration increases, the risk of their own vendors increases, as well as in which environment you are hosting. The GKE you are using might be secure, but the environment the account you have invoked before having this GKE instance in the account might not have a good IAM configuration. You didn't check that, but you ran GKE in before that. So it's kind of a whole checklist which you have to follow every time. Very tedious. Automating it, it's a goal which we used to try to achieve, but not always it's possible always. So yeah, so now we will be just moving on to some real-time attacks which we see. The main one is, which I think most of you have heard about, is the review dog, or most likely called as TJ action. So the TJ action GitHub action attack was initially detected on 5th of March, but it was not recognized as an attack. Then on 14th of March, it was finally detected by Step Security, and then they were finally, there is a secret exfil, and that's kind of a very long cycle of investigation. I was coincidentally in the place, I just happened to publish a blog about that, and then find out that so how these things are going around. And then specifically for the interesting part is that if you see here, we are always trajectorying it as a TJ action attack, but interestingly, after 1 week of investigation, we found out that no, there was another action, review dog, which kind of was the culprit, whose PAT token was used. Okay, but after 1 week, we found out another parent of that review dog, which was Spinbog, something like that. So it's kind of, that was the first GitHub action which was compromised, whose PAT token was compromised in the first week of March, and then that led to getting compromisation of review dog, and then that led into TJ actions compromising. And the original target was Coinbase, but that led into a very long dependency cycle, which led into a dependency attack as well. So in the case study, what exactly happened? So actually the memory dump, which was used written in Python, which kind of was a memory dump, which was trying to be which was a script which kind of added into the GitHub action through the PAT token, and that kind of, when executed, it's kind of we forgot that the secrets are usually stored not in the log, but it's usually stored in the secret manager or something. But for in the temporary time of action, it's always reflect on the log. So this was one thing which the attacker used, that when it is temporarily been shown in the log, at that time it's kind of picking that secrets from the log directly, and using this, trying to exfil the secret. Another interesting thing which he used was double encoding the secrets, so that you can bypass the GitHub secret detection, automated secret detection. So that was another fallacy. And then finally the workflow kind of try to exfil the secret, but in many of the organizations there were some security control in place, and which kind of detected it at the time of exfil, not before that, but at the time of exfil it was detected by one or another monitoring tool. Sometimes it was some SIM monitoring tool, but what I have seen is mostly when a monitoring tool is integrated with GitHub Action, those were much more effective. So what we learn and impacts on that. So first of all, exploiting the trust of the organization, as we always, any security engineer or a guy who is working in security, they will totally know when we talk with any dev, even before Gen AI, they usually trust on any recognized third-party repo, library, doesn't matter. If they know that this is a popular one or this is very useful one, either case, so they will use it unless you have an automated security control to block it. They will just come to you to raise another ticket and ask for permission with some business use case. Sometimes you have to agree, sometimes you can deny it, but yeah, that's the whole process, and that's the exploited trust which attacker usually use here, even in this case. And the second one is CI/CD is a whole attack path. Just like I mentioned, the secret was in memory, not in file, but even although we think about that, it's not, if it is not in the file itself, hard coded in file itself, so it should be secure. But even for log files, it can be exploited. So again, the broad line of the types of hidden risk or hidden risk which was identified in this attack was first one is transitive trust risk. Like as I have explained, that the three different actions running in different organizations led into this attack. So once was running in Coinbase, another one running in unnamed organization, and the last one was running in some 23,000 organizations. So yeah, so it's kind of can be a very transitive trust risk which we have to deal with. And one of the ideas usually I've seen regarding that, you have to have a better SBOM connected with your threat intelligence. Then only you might be able to recognize this kind of stuff. If something happened with the parent trust chain, then you have to have that public disclosure into your pipeline. You don't have to look into that whether this kind of has been disclosed. You should be knowing before that, and that threat intel, if it is connected with these third-party dependency and SBOM, then you might be able to do it beforehand. Or else it's always incident response. You can always run for that. And then the second one is public log, and yeah, the third one is the memory inspection vulnerabilities. So these temporary secrets in the memory or in the logs, which can be very, it's kind of a very hidden risk. I can give this example of which happened, I think 1.5 years ago, when I was investigating one of the third-party library for my organization. This was the exact thing which I found, that we are able to see secrets in the log, but the direct response from the developers, experienced developers, that okay, so this will be available in very temporary find. You will be able to see for a couple of minutes, and then it will be out of the logs. So yeah, it's not that there. Although we don't store these, we are not storing these logs. This is a temporary log. So now I have gone back to show this use case, and we have already taken some action for the security control. So yeah, these kind of attacks does help for security point of view, but yeah, we try to avoid it. And so the fourth one is the dependency depth blindness for in case of monitoring. Unless you are monitoring, as I was speaking earlier, unless your monitoring is integrated with your threat intel, with your SBOM, all the third-party dependencies are connected into it with the right configuration, you won't be able to detect it. you won't be able to detect or mitigate these attacks. Okay, you have to keep rolling it, and yeah, so the last one is I can, let's skip. Okay, so yeah, again these common mistakes are related to over permission integration, how much time, yeah, and other behaviors, and patch management of third-party tools is been delayed. Just another point on the fifth point, the delayed patch management. Usually we talk about that 90 days or sometimes pushed to 180 days, but for non-IT sector, specifically for manufacturing, we have firmwares. It's not softwares always, it's firmwares, and these firmwares are essentially another images. So these firmwares are container images which need to be pushed in on the system physically or over the air. You cannot expect 90 days there. So the patch management sometimes takes 18 months as well. So this kind of a very, it's been written as a common mistake, but it's kind of a limited functionality as well, which we cannot mitigate right now. So we have to beware for other security controls. We cannot believe that there will be a patch management even though there is a patch available. So now we will be discussing a attack similar to what happened with TJ action. The kill chain is like that. So we are assuming that the recon will be done by the attacker. This recon can be based on just happen to find some cloud account, some some public cloud repo where they happen to find some GitHub action. In this case, in the case of TJ action, or in case of any other functionality where they are not able to see your cloud resource or any resource, but they happen to know some architectural information where they know that your payment system is running through a Lambda function. So using the exploitation of Lambda function, they might try to work something there. And the second step will be weaponizing your indirect dependency. So simply you have to identify for Lambda, you have to create a Lambda backdoor and then look for compromising one of their supply chain tool or supply chain tool chain, just to have the wrapper inside, and that can be published with your hidden risk or hidden threat in this case. And if you are able to your package is able to be pulled and delivered into the system, then yeah, voila, you have achieved something there. And then you have to the attacker will try to install it with the delay activation, because you don't want to trigger directly, which was the mistake with TJ action, as it was executed at the time it find out a secret, it try to exfil at the same time. So you have to have some delayed response to that, where it will be triggered at the time when you think, okay, this might be not the time when the monitoring tool might be detecting it. So you have to have a weighted trigger, and then data exfil will be sending the secrets to the attacker, and then exploitation and persistence. Now we can we can skip this one. So the installation of malicious package can be like this. The npm package will be having your npm pack. So as I was discussing, for npm, if you are trying to do the npm install directly, your GitHub action or your environment will try to block it, and because it's actually detect the malicious exfil. But if you are somehow manually installing it, it doesn't care about that. So I was able to manually install it, and then the npm install, you can see the demo helper util, that's a malicious package which kind of install in the environment and executing the code directly. And basically this will lead into the attacker server, just exfilling whatever is in the cloud server. So in this case, the log will be displayed with the credential. So in my own test environment, I was able to do that. And then the second one is, these are the stolen secrets regarding the AWS account, because this environment was deployed in AWS with ECS, and that's exfil was resulting into these things. Then the main interesting part is that you can go ahead and get these stolen credentials from S3 buckets, or you can actually store this you can actually store this stolen credential into S3 bucket, use their cloud, use the client or your victims cloud resources, and then basically find out that what more you can do. So the second step is always to actually expand your IAM privileges. So in this case, I found out that this was a CI/CD deploy role. So just to add to that, from perspective of getting admin access is always the case. We want to root the shell. So that's the second step, which kind of provides the thing. So this, of course, for the test environment, I'm taking a lot of privileges with keeping these roles with lesser with more excessive permission roles. So that's why I'm able to do this. But if you have a very defined permission rule, you might be able to block it. And then establishing persistence is the best thing which you have to do. Again, using, if you find out that there is many Lambda function is running in the supply chain, so you can just create your own Lambda function just to monitor the mechanism, and whenever any Node.js application is running, your application will be running at the same time. So you might be able to bypass the monitoring because similar kind of application is running at the same time. So your application will be similar, look kind of similar, not malicious. And then you can continuously check for the system for monitoring whether you are getting the input back or not. So that's kind of the input screenshot. And yeah, so that's pretty much the attack simulation. I was planning to have this live demo, but I tried to avoid it because mostly demos doesn't work at the time of running it. So these are the screenshots which I rely to. So then the defense strategy playbook is there. This is not exhaustive, but this is the most important one which you should have from the perspective of having dependency mapping. Using SIFT and Trivy, you can have your generated SBOMs, and dependency automation can be done. Then the architectural integration need to be very secure. Multiple attack path which I showed will be easily blocked if you have a secure integration. Even if you have a gateway Lambda, if you have set API gateway with your Lambda function, blocking or filtering out these connections, even that will work. So this kind of segmenting those for isolating the patterns which can be leading into these external integrations. So just not allowing the integration, we have to also have the type of integration is going on with the time as well as the monitoring specification. Those need to be figured out. Although there will be many false positives, that's why many of the developers avoid it. But yeah, this kind of need to be checked with the baseline. You cannot just go ahead and deploy it. But then the runtime security is using Falco is one recommendation for anomaly detection in the container. And the last one is always check for the code sign, just for the signatures, verifying the package signature before installing any dependency. Again, there is a segue on that. Again, going back to, because with IT organizations, this seems like very easy to do from TLS connection or even code signing. You can achieve. Usually, you have a PKI as well. So, in manufacturing or automobile or in non-IT sector, this kind of implementation of a PKI is still going on in many of the organizations. So we always used to rely on code signing. So code signing, if basically you are signing your package and then mapping it with at the time of your router or whatever your receiver is, but you are storing the certificate somewhere, and that's another hidden risk there. So that need to be also taken care of. So we have to have monitoring file integrity as well. So you cannot rely on just package signature. So having these image integrities as well as file integrities, image integrities at the time of container registries and Kubernetes there, and at the time of getting the supply chain running on, the file integrity need to be continuously checked with at every component, moving on from backend to the system as well as to the your user end users. So that's pretty much there. There are other security controls which is always there for authentication authorization, having the regular shared from RBAC to getting the git commit signing mandatory, as well as for git we do have for git we do have artifact signature mechanism provided by Sigstore. I think last year in June that has been started, so that artifact attestation can be also enabled, and that enabled and configured. Then the last part is the supply chain transparency. Again, the verifying the artifact with the attestation is one thing, but documenting the chain of custody from end to end, that's also required, specifically when you are looking for that threat intel part for monitoring. This chain of custody will help you to monitor as well as for IR. So that's also which I've seen that many of the organization doesn't document it. For chain of custody, we do have artifact attestation, but the chain of custody, when it is going out of GitHub, it's not there. So you have to have the full province there. So this is another example of how you can generate the SBOM. On the left side, you can see the SBOM of the test environment which I created. That was there, and on the right side, this is showing the grep output for the malicious package which was added, and it's showing it as unverified source. So if you have this tool in system, you will be able to at least visualize that, and you can use that for your information. So then setting the runtime monitoring with Falco. It's I have set for this one, I have set the bare minimum to detect and show the exfil, and as you can see, it is showing as warning for suspicious output connection. I tend to have this habit to have everything as warning, because you never know what is false positive. So you cannot directly block a connection unless you have already done it for a training set and have a baseline. So for initial connection, I always recommend to have a warning for testing around for a couple of times, and then you can move on to start blocking and sending these information to your SOC team. So, but this kind of is what should be there for detecting any exfil, detecting any credit exfil, from providing the enumeration process, as well as for checking for all the access keys, getting the credential report. So all the items should be tested on for a better Falco rule. Previous one was just a sample one. So the next one is a sample for policy policy or rule set for policy privilege escalation. It's kind of similarly checking whether any of these administration access or any attached commands are there. So it can detect if any user is trying to do this, and in your log you will be seeing that whether this is a trusted source or trusted user or trusted IP address. Based on that, then can be integrated with your SIM as well. So yeah, so that's pretty much it. So again, repeating the same stuff, automate your SBOM validation at every push or every push PR, and shifting left always is the best case scenario. Doing it from your design phase and working on those secure integration of the architecture is the best when you are working with the architect team to see the API gateway can have these different lambda rule set. That will be the best thing if you have to do, and then you can work on to collaborate with other other vendors to have those transparency fosters, those SOPs. If anything happened or any breach is happening or any attack is happening, what should be done? So those collaborative transparency should be done with all the vendors as well as third-party dependent vendors one. So yeah, but there is always a question that how you will be able to do this collaboration with any third-party library which you are just pulling in. So what I have recommended is to have your inner policy. At least you should be knowing what you will be doing. So you can wait for the transparency or the public information of the breach or of the attack, and then you can act with the vendors. So similarly, having a conscious culture like training and user training, developer training is always great, specifically for third-party supply chain attack, which for me in one of the organizations when I joined, it was open stuff. You can actually use any third-party library or any type. It should be only one condition was there. It should be a trusted GitHub repo. You are not allowed to use any non-GitHub repo. But apart from that, there was no policy in place. So I first provided the third-party policy for the whole province, which we have discussed, and then implemented those security controls which we have on GitHub, but not enabled because sometimes it's cost problem because a couple of features are available in advanced security, so company doesn't want to enable it. So yeah, but specifically even if with your Artifactory, sometimes the advanced, so Artifactory is also the same thing where you will have to have those collaborative sense, not with the vendors but with your product team as well as your leadership. So that will also help to create this conscious integration culture. Yeah, that's pretty much it. I think I'm overboard now. Any question will be happy to answer. Yeah.
So you had mentioned
I'm not
secrets.
I cannot hear.
Oh, sorry.
Yeah.
You'd mentioned secret scanning and memory dumps early on.
Yeah.
And I'm curious. I know that a lot of tools will dump stuff into the environment, and that makes it a particular target for this kind of attack. Have you come across any tools that offer an alternative to runtime level security secrets that don't get embedded in the application?
Yeah. So okay. So you're asking that whether there is any tool which doesn't do this?
Yeah, that would be like other tools that might be a better fit for solving that security problem.
No, you have to have. Yeah. There is no tool which not doing it. They are doing it better, means hashing and other stuff, but even that can be bypassed. So right now there is no other alternative apart from having your monitoring trigger tool better.
Got it.
Specifically, like for GitHub Action, you can have dedicated vendors which are working better than what you have with GitHub, or even setting your own Falcon monitoring, because their Artifactory province is better. That's the only thing. What I'm seeing is, specifically with this attack as well as with the XEutil, there are vendors who are working with and trying to improve it. That's why I'm seeing these hash and other stuff.
Yeah.
I'm looking for a better solution when that will be there.
Right.
That will be best to go ahead.
Awesome. Yeah. Thank you very much.
Yeah.
All right.
Yeah, okay.
I guess we're up. Thank you very much. Yep.
Thank you. Thank you for listening.